good question that you have to really break down on multiple levels. So how on a physical level does ATP confer energy? Now, yes, you're right. ATP plus the addition of water causes the hydrolysis of into ADP and phosphate energy. Um, and then you have the chemical understanding of all that stuff. But from a physical perspective, ATP is processed through an ATPase pump. Now, if you have a background in chemistry or biology, then you know that um, the ACE suffix means that it's an enzyme, right? So ATPase is going to break down ATP into ADP or vice versa. Then what happens is this creates an imbalance in the amount of ADP and phosphate that's free, and the other thing that it does is it creates an imbalance in the amount of hydrogen ions. So the ATP VACE is the one that you're most likely talking about. The only difference is the actual mechanism, but in large part it's the same thing. So this creates a large imbalance in the number of hydrogen ions. One of the best ways to understand this is to look at it through the glycolysis pathway into the Krebs cycle, down the electron transport chain, etc., which is the basic understanding in biochemistry and in biology and chemistry that we use to understand how ATP works. So, through the process of glycolysis, glucose is converted into pyruvic acid, and then the pyruvic acid goes through the Krebs cycle, and then Krebs cycle goes to the electron transport chain, and obviously a lot of byproducts are coming in and off, and there's a lot of energy being created here and there, but all this energy is in the form of either ATP or ADP. And this ATP goes into this, goes down this chain, and finally gets to the ATPase. Now, the ATP, what it does is it gives the actual physical energy required to turn this mechanism right here. So it gives the ATPase physically through some sort of chemical bonding, causes the churning of that turbine. This is the ATPase behaves as a turbine. Now, when that turbine turns, the hydrogen ions can go across the cell membrane. The cell membrane would be something like right here. So the hydrogen ions can go across the cell membrane and create a proton gradient or a hydrogen ion gradient, whatever you want to call it. But we call it proton gradient because hydrogen ions are positively charged. So it's a proton gradient. And because the ATP is binding and unbinding and binding and unbinding, and it's causing that thing to turn over and over and over again, hydrogen ions continue to flow across the cell membrane into the interstitial fluid, the interstitial cellular space, or the extracellular space, depending on the type of ATPase we're working with. That creates another potential for more molecules to come across. So if you have this is outside the domain of ATP specifically, but it's a good thing to talk about because it's a good understanding. So the ATPase pulls the hydrogen ions in, and because there's a larger concentration of hydrogen ions here, it's easier for hydrogen ions to go across in the opposite direction without any channels, without any ATP. And that's in the larger scale of things how a lot of things happen in the body. But ATP itself is a turbine mechanism where the ATP comes in and the ADP and the phosphate breaks off because of the interaction it has with these subunits of the enzyme itself. The opposite over here is FATPase, where the ADP and phosphate come in, and then ATP comes out. And to do this, the turbine charges and turns in the other direction. Now, this usually is going to be happening in the exact opposite, whereas VATPase, the ATP comes in, turns the turbine. This one, the proton gradient, is going to be turning the turbine to create energy. So the question is simply, what does the protein look like? And what does the protein do? Where does the protein exist? And what is the primary function, right? So for example, if you look at muscle cells, you're going to have a lot more of this VATPase because you're going to need a lot more energy. You're going to need to use a lot more energy. Whereas if you look at something maybe more like the liver, you're going to have more FATPase where you're going to be creating energy because you're going to be getting the nutrients from the blood, you're going to be getting the nutrients from the diet, and then that's going to be going to the liver to be processed to store into glycogen. So you're going to have more of the other kind. So what's really interesting about the body is it knows exactly what the form really follows the function.